I'm here today to show you how to use the new AppMap Navie. AppMap Navie isn't just another AI code assistant, it's the missing link that improves the power of AI code completers and code assistants. Leveraging the unique ability that AppMap has to understand your code's execution at runtime, Navie transforms this data into a powerhouse of hyper-personalized, context-aware insights for AI-assisted coding. That means you're not just working with static analysis anymore, and you're not looking at just individual files and functions. You're stepping into a realm where Navie can actually understand the entire code base at an architectural level, how it behaves and executes, and provide much more detailed answers to your software questions. So in this example, I'm a software engineer working on a Django-powered web store, and I've been tasked with adding a CAPTCHA for the registration page here. I've got AppMap installed with my project already, which means as I interact with the registration page, it will generate AppMaps automatically for my service. You can also use tests to interact with any part of your application to generate AppMaps. And you can see here that navigating these AppMaps, I can see this API request all the way down to the database and all the code interactions in between. So now I can use this data to ask AppMap Navie what areas of my code base are involved in the new user registration service because I want to find all of the files so I can add this offline CAPTCHA. AppMap Navie will now search through all of my AppMaps and provide the detailed runtime sequence diagrams as additional context to the generative AI. I can search through my AppMap data based on my request and send this data along to the generative AI service to get a much clearer view into exactly what files I need to find and edit. Now, if I was using a AI-powered code auto-completer, I would need to already know what files or functions that this request hits. AppMap can see how my code executes, and Navie provides the AI with this context. I get very clear and direct insight into exactly where I need to make this code change. I'm going to ask for more specific information on how to implement this change. So let's review now what it recommended. First, it's going to want me to install the Django simple CAPTCHA service, which we'll do here. Then we're going to add the application to our settings file. Next, we're going to follow these steps and update this line right here in our urls.py file. And in the next step, we'll need to update the registration form at forms.py. So we'll go open that file here, and we'll add that first line to import the package. In the next section, we need to add the CAPTCHA to the form, but it didn't tell us exactly which function we need to add that into. And looking through this code, I'm really not sure where I need to add this. So I think it's time that we ask another question. We'll ask Navie about this specific library, giving it additional context, and you'll see a simple example on where we can add this feature will be given back to us. By asking this question with this more specific context, you'll notice that Navie is telling us to add this line to the email user creation form. Now let's go back to that file and search for that function. And now we can see right here is where we'll add the CAPTCHA in the right location. So we've already added it to our installed apps, but we have not yet run the database migration, so I'm going to do that now. With our database migration executed, we can continue the steps and update the HTML template for the registration page, which I can search for here. Using this registration template, we can copy the code over from Navie and paste it into the section above the submit button. Now let's give it a test. We'll refresh our page, head over to the registration portal, and you'll see this new CAPTCHA field has been created. So let's test this out. We'll fill out the form and complete the CAPTCHA correctly, and you'll see the user account gets created. Now let's do it one more time. But we'll register our account with an invalid CAPTCHA. You'll see the registration has failed and the user was notified that the CAPTCHA was incorrect. Now you can see how AppMap improves the AI coding experience across your entire application. If you asked similar questions to a standard AI assistant, you would only get generic answers based on existing public knowledge. Without knowledge of your code, these generic responses will leave you continuing to hunt and search through a complex code base. With AppMap able to see all of your code's runtime behavior, it can now provide these context-aware insights that power these hyper-personalized responses to your software questions in your code editor. In this example, I'll be showing how AppMap Navie streamlines the process of crafting a detailed pull request title and description for this recent update that I've made to the CAPTCHA mechanism on our registration page. Here's how it works. Upon posing the question to Navie, it searches through all of the app maps to pinpoint the exact code segments where the registration logic is implemented. This search returns a collection of app maps which include aspects such as sequence diagrams, performance flame graphs, dependency maps, and trace views. Leveraging this rich dataset, AppMap can communicate with the generative AI service, which in turn provides very succinct and a precise overview of exactly how this updated functionality operates. Thanks to the runtime data sourced from AppMap, the AI can then deliver these specifics, including SQL queries involved in generating and storing these CAPTCHAs. It can identify the modified files, supporting the new logic, and suggest test cases to verify this update works. To further ensure the quality of the AI-generated code, I integrate AppMap with GitHub Actions for a runtime code review directly within the pull request workflow. This review, performed via GitHub Actions, flags potential issues such as an anti-pattern in our CAPTCHA handling approach. Accessing the AppMap directly from my browser, I can gain insights into the operational dynamics of this functionality. For example, initiating a GET request to the login form now triggers the creation of a new CAPTCHA and an insert into the database. Delving into this trace view, I can trace the CAPTCHA generation process, starting from the registration form template all the way back up through to the API request. Moreover, by examining this sequence diagram diff, I can assess that the changes made here, revealing that this latest adjustment will insert a new record into the CAPTCHA data store, again, every time this API endpoint is hit. This end-to-end process not only enhances our understanding of the changes, but also facilitates a much more informed review and discussion around the pull request. To learn more about AppMap Navie and AppMap in GitHub Actions, head over to getappmap.com.